So all of you are working in AI, machine learning, deep learning. So first question is to you. Are you intelligent? Of course. All are intelligent. Okay. So what exactly is intelligence is all about? What is intelligence? Because see, I go to many of the interviews and other things. So after doing PhD and other things also, people find it difficult or challenging to answer some of the very simple questions. So what is anyone just
intelligence cannot be mapped. It can be compared with any other.
can be compared?
Yes. We can compare someone is intelligent.
Yeah. Acquiring knowledge and applying knowledge. And what about this? Is it an intelligent device or a smart device or both? Smart device. It's not intelligent?
No. Intelligent is someone
It's
which
not
can
intelligent.
be trained.
Can you name some AI apps?
AI,
How many of you have the idea?
ChatGPT.
No, I'm talking about AI apps. That's inside your phone. See, these are the things. Sit down. Anyone? ChatGPT. ChatGPT is there. Many are there that people are using. Now this what this Google Map. Yes. This Google Assistant. What is that? It's not AI.
Yes.
Is it AI or not?
Yes.
It's AI. Now the question is, what is learning? Machine learning and then what is learning? And how a human learns, then we come to machine learning. See, these are the questions. If you are going for a job and other things, people may ask. Okay, let me explain. How a child learns? Because the same analogy we are applying here. How a child learns?
So training experience by some training.
Yeah, by some training. Okay, the next question is, what is the first thing a newborn sees when he comes to the world? जब बच्चा पैदा होता है उसके बाद पहली चीज क्या देखता है दुनिया में? And what he sees? Can what are face, wall, and this? What are these? In computer science, what do you call these things? All patterns only. See, all computer vision works on patterns only. The same way, when the first thing that we see is patterns. Now, how the child learns when he goes to school? How he knows that this is apple, this is banana, or this is fan? How he knows? How child learns? No idea? You have an idea, but you are not able to express, I think. Yes?
We train them and we talk.
How you train them?
Yes, sir.
See,
So by showing image of it and
yeah. What is that learning?
letting it know that this is the image which we call.
Okay. Sit down. I'll tell you. I'll repeat the same thing what people have studied and then see. When the child goes to school, then how he learns? As in way, unsupervised way, and reinforcement learning. Now I'll take a simple example. In one hand, I'm having banana and an apple. What I do? I'll show the child. This is apple and this is banana. And how I describe? Describe the features. What are those features? Round in shape, red in color. Banana is somewhat cylindrical shape, yellow in color. What we are doing? We are labeling the data and telling the child that this is this, this is this. Isn't it? This is how child learns. What is learning is called? Supervised learning. See, people have learned these things, but next what happens? A green banana comes. What will happen? The child will get confused. Again, what we do? Again, we label it. We say, no, it is not right. This is also a banana. Then child learns. What we are doing? In the learning process, we are training the child with the data. Isn't it? Same case here also. This green apple comes. This what happens? We also say that yes, this is also apple, but of different variety. So this is how what we do. We train the child using this supervised method by labeling the data. This is what you do in supervised learning. Next, take a big basket and two small buckets. We mix banana, apple, and other some fruits, and tell the child take out the fruits with different shapes and colors and put it in different baskets. What will the child do? He will take the banana, he will put in one basket, apple in another basket. Isn't it? What the child is doing? He is doing clustering. This is unsupervised. Simple terms. What is the next? We ask the child to write. If he goes in right direction, we give him some positive marks, otherwise negative marks. Then what type of learning is there? Reinforcement learning. This is what you simulate here in computers also. Same thing. Learning of human you are trying to simulate. This is what machine learning does. Isn't it? Okay. Now coming to my, so most of the things that I am going to do is, first one I will focus on the projects that I have done because of this. Okay. So one by one I'll go just move on. First. So, this question is because my talk will be some interaction modeling. Then after that, I'll show you what I have done. So what are real life problems? From morning to evening, or since we have taken birth, different phases of life, we face different problems. So we have to see that what problems can be solved using AI. Isn't it? So this is the human life cycle. Artificial intelligence. What is? It is just a simulation of human intelligence. This is what we do. Yeah. People are familiar with it, but anyway, I just go past this. Now the question comes, what is the limitations of human mind? Do we need all the this we can apply machine learning or deep learning to every place? It's just one question again. Can we apply this machine learning or deep learning to for searching and sorting? Yes or no? And if yes, then why don't we apply? In data switches, if people studied searching and sorting, why we don't apply this machine learning and deep learning there? What is the reason? Huh? We have exact solutions. Instead of the what will happen if we do with AI? It will require lots of data and it may bring some randomness and some errors also. So these some of the places AI cannot be applied to everywhere. So we had to decide where can go for AI and then we have to go for some algorithmic approaches. Being in computer science. So, some of the places, suppose in computer vision problem, can I this human being properly explain that seeing my face and giving the description to others? Each person will have different descriptions. So these are the places where this computer vision or AI is applied. First question is why learn? Why machine should learn?
But mistakes.
We don't the same thing. We don't require every place for every applications we need to learn. So what we talk about when we talk about learning? Yes, what comes to your mind? Learning general models from data of particular examples, and this data is publicly available. These are some of the examples. After machine learning, why DS is deep learning? Why is it useful? And again, my question is when we should go for machine learning and when we should go for deep learning, or both are equal? And which one is advantageous and which one is less advantageous? Yes, any idea?
So it,
How you decide that when we should go for machine learning and when we should go for deep learning after seeing the problem? Or in another way, I ask you the difference between machine learning and deep learning.
It's a complex algorithm.
Complex algorithms,
It is complex data.
complex data, then clear. Any more answers?
so for better accuracy, we use deep learning. Like in some cases, like
So this is the criteria.
so this is not only
to
the case.
extract the features by itself.
Yeah, this is one of the features. See, if you have less data and less computing power, then we go for machine learning. If you have abundant data, sufficient data, or you can say more data and sufficient computing power, then generally we decide to go for deep learning. Because of course, deep learning will give better results compared to machine learning. This is well known. So this is how we decide. Another feature is that in machine learning, you use this handcrafted features, and here the features are accepted itself by the models. So these are the places where this DL is useful. So I'm just showing this picture because now what I'm going to explain is that I'm doing one project. This benchmark 1.2 come from this ICR and from private agency also. So we are going to deliver the solutions they have asked for. This heritage to latest, the startup is company. So we are going to deliver. We are not money from there. Money is there. So I'll just tell you in brief that what we have done and what we are going to deliver about my project that we are currently working on. So any idea after seeing this picture? What comes to your mind that what problems might have solved here? First, it is related to some cattles.
Yes.
What problems do you think that we are trying to solve?
There are a lot of we tried.
Center. Make a center for the country.
Shelter. Okay. Okay, one more thing I would like to ask. If you are given this 20 Chinese faces and 20 Indian faces, Can you recognize them? It is 20 Chinese faces. Yes or no?
Yes.
Yes. What about 50 Chinese faces and 50 Western faces or African faces? Can you recognize them? That yes, this is the person. Don't say yes. Don't say yes. If I'll show you just forget about 50 here, just 20 only. You'll not be able to identify. Am I right or not? So what is the reason that we are not able to identify African faces, Chinese faces? Are they same? सब एक ही तरह दिखते हैं, सब एक ही होते हैं. That's not like that. So what is the reason? Anyone thought about it? Yeah.
We are actually not aware of that, but this is we are not identifying.
Yeah, so tell me properly. See, our mind is not trained on that data. Talking computer science. As in the model also, our mind is trained on some particular data only. Then only we perform. Then only this bias and other things comes and other things based on the data only. So we are able to identify this Indian faces because our mind is trained on the Indian face data. That's why we are able to. Got my point or not? Now, if I ask you to recognize a cattle, then what will happen? We are all look alike. This is a problem of look alike. Can this machine do it or not? Can MLDL solve this problem or not?
This can.
It can solve.
Yes.
How many say it can solve or how many say not solve? Okay, we'll see. We'll move ahead. Let's see. What comes after seeing this picture? See, this idea came when I was going to my home. Then I saw this tag on this. Why this tag is there? To identify the cattle. So the idea came that why can't we recognize by their face? From that. So this is how this striking about this is how idea came to me. Then I asked my research scholar, explore this, go and take some photographs. BHU is the big university and he have veterinary department also. So we got some data, this data, and then we started this one. So for doing any work, we should have some proper motivation. Otherwise, just recognizing the face of the cow, what difference it's going to make? At least we should solve some good problems. There should have some applications, good applications, so that funding agency or research community can accept it. Yes, it's worthwhile solving this problem. So these are some of the motivations for doing this research. Their health monitoring, their insurance, many things. Most bad thing about is that when the student's claim is made, what they do, they cut the ear and take it because they punch it. And that is verified. That is very inhuman task. After that, you have to claim the insurance for your this kettles. Then that is what is happening at present. So these are some of the reasons or motivations that you can say for doing my work. So this is a project that we submitted to this LCR. We got sufficient funding. And as I told you, 1.2 crores. Me and Indian Veterinary Research Institute is 70 crore less for IIT BHU and remaining to them. So they provided the data, sufficient data, and we were the ones who. But what happened when we went to them? This funding agency. They told that already we had that. So they told you have already done for this cattles. Because we are India right patents, now we have patents also granted. Patents. So what is left now? So they told that now you go for small animals. So cattles we have done. Small animals, sheep, pig, and goat. So this is the challenge they gave it. That we are still doing it. The data is being collected, some from the models we are testing on some open source data, and we are getting real data from the IBRE, Indian Veterinary Institute, that is in UP, that's very. So we have collaboration with them. So this is the background and rationale for. See, I've made the slides from there, what we have submitted. So you'll find some of the slides from my project proposal only. Because no one is going to give you fund unless until they you convince them. So these are the reasons and the problems they are going to solve. So you can say that how this creation of AI that we are making to solve these issues, or you can say challenges. And for this, what data we are capturing? See, for machine learning and deep learning or AI, you need what do you need? Data. Without data, no AI, no ML, no DL. So these are the data sets that we are trying to collect. Some we already have, some we are getting. Some are primary data, some are secondary data for this. So this is a justification. For our proposal. And these were the 4 objectives for our proposal. And one more thing, I'll just show you the images also. So we classified into 4 activities and these outputs of our proposal. So we have tried all those things. ML and DL algorithms, well known algorithms that are available. So this is all about objective 1. See, there are many ways in which we are capturing the data. One is to surveillance camera also we are trying, but at present what we have tested is from frontal this app. So to recognize a cattle, we need this front full length view. Right? These are all the data that we require, and as well as muzzle print, not the mouth part of the cattle. We were the first one to recognize and file the patent and publish the paper also. That cattle can be recognized based on the muzzle print. That's mouth part. And we concluded that it is somewhat like our fingerprint. So this is how we have made some protocols and then collected the data for the petals. Add this how we have segmented the images and then doing it. Slides which I'm showing this. We prepared for the funding is in the same slide I'm showing to you. For that, I'll show some of the slides and homework also. These papers we have already published in reputed journals. So this is our cognizance system architecture. We are collecting the data through mobile app, files. Or we have prepared the app for that, and we are getting around 95 to 96% verification accuracy. Now we are allotting unique ID to all the petals and then running it. At present, we have done it for 500. Now we are scaling it for 5,000. This is how we have planned. We are still doing this about boards. Here you can see facial images. Here you can see sample puzzle print images. So these are some of the results that we got using different deep learning models. See, these are the well-known techniques. All of you must be knowing this resonant exception and models. They are well-known models. Only what we do in deep learning, we just fine-tune the parameters and have a parameters. All the codes are available on the GitHub. Isn't it? So what novelty you have to bring? Either the problem should be novel, or you make some sufficient contribution at the architecture level. So here we have also done. So these are some of the sample images of goat, sheep, as well as we are also trying to find out some of the diseases also. Our next phase is getting the what we call pictures of eyes and then try to predict some of the diseases or health monitoring of animals. But see, these animals can't speak, and they so we have to take care of them. Was objective 2, and these are the activities there. We are also planning to use or started capturing using thermal images also. So what is the advantage of thermal images? Any idea? Where we go for thermal images? Or infrared camera? What it provides? It provides the heat pattern. Suppose you have fever, detect it. Or pain is there. So what happens? That area, the heat pattern will be. So those things are detected by the thermal camera. So these are all things in the computer vision only, AI. This is our third objective, where we are planning this smart app, phone apps. The architecture of our app and phone model. So this is the digital signature that we are taking it. This is our vulnerability, that is both ability to integrate artificial intelligence for computer system lifecycle management. This is the overall picture. More than 1 year is over, 2 more years are left to complete this project. So this is the overall output that we have committed to them. Now, I'll come to this for the research part of this that we have done. So, as you can see, this tags have its own limitations or disadvantages, that it can be spelled and replaced on other things. But our method is foolproof. So, this area comes under this animal biometrics, the whole area, comprising this biometrics is for human and animal biometrics for peoples. So, how to recognize? So for that, we need some unique features. In our case, we have taken space of animals as well as some unique features like muzzle print in case of cattle. And here you can see for different animals, we can have different unique features. So these are some of the traditional methods that were used earlier. So this is the data set that initially we collected. Now we are collecting more data sets. Based on this, we published the papers. So different breeds of cows we took, and as you can see, the statistics of the data that we collected. More closely, you can see this muzzle print images. Somewhat similar to fingerprint. Just show you that how we have pre-processed and processed the data. All images are there. Some of the models that we have used earlier. Here we use for machine learning or deep learning. Initially we started with machine learning, then we went for deep learning. So these were some of the publications based on this data. One patent granted to apply. Papers are there. Now, before going to this, one more work that I did before this. Again, the case of look-alike only. That is also very interesting one. Once I read the newspaper that baby was missing from the hospital. So I thought that whether some solutions can be there for that or not. So since we were already working on biometrics, so I asked my research scholar to collect the data of babies. So for that also we blocked our efforts to collect the newborn face images. So this is another case of, but this work was done before the present one. As you can see, it's really very difficult to recognize them. As you can see. So these are the motivations. As I told, this protection, the swapping and other things are there. This. So here also this when we did this work was really appreciated and we got the best poster award in biometrics conference that was held in Washington, this BETA's conference. So for the first one to capture these images of newborn and then publish it. So this is how we collected the data from BHU hospital. We collaborated with the hospital people. And as you know, this collecting the data itself is a very challenging task. No parents will allow you to take a photograph, other issues are there. So you have to, ethical clearance, it has to be there, permission of doctors as well as the permission of parents also. So it becomes somewhat easy when the doctors are there. So for some studies, they allow it. So this is the statistics of the newborn that we collected. And as I told you, getting the face image of human, ours is very easy. What about newborns? Getting their normal face is very challenging task. Why? Because most of the time they are sleeping, or when they get up, they cry. Or very few times only they are in normal positions. So that was also a challenging task. So we collected all the data. It's whatever you could get. So pose, problem of pose and expression was both, and illumination was we tried with different illumination also. So this is the statistics that we collected for different expressions: neutral phase, crying phase, and sleeping phase. Collected. Because when you go for doing research, you have to collect the data in this one. And have to have. See, this is that's all the neutral phases of newborn.
Getting guys, which of it is children are having the neutral faces based on
See, just I'll go back. This, if they are open eyes and they are in front, we consider them to be neutral. If they are sleeping, three categories. If they are sleeping, they are in sleep mode. And then crime is let's show you the crime phase also. So we have taken three categories. So see this, if they have opened their house, any expressions, we consider it to be neutral. Like a human being. If some people stand like some what's fine. So we consider it neutral. So three expressions we have taken. This is a crime phase. This is sleeping phase. So it was really interesting for us also seeing the kid newborns and like this. Okay, one more question I will put up before you. Whether just guess it. Who do you think is better at recognizing the newborns? Is it doctor, mother, or machine? Who is better at recognizing this? Do you think will be better at recognizing kids? Mother, doctor, and
Machine.
huh?
Machine.
Mother. I'll come to that. Okay. Who said the doctors and machines? Okay. After this, I'll just show you my results. So, as you can see, different illumination conditions also, different lighting conditions. Sometimes blurred images are also there. It's also taken. So when you go for publishing a paper, you need lots of things. You have to show the challenges and how you solve the challenges. Those things have to be taken care. This is also this. Soon after what? That. वो करते हैं ना? ये भी है. मुझे उन्होंने images दिया. We also took that. And apart from this, we took the images of ear also. Because ear biometrics is also established technique. And this ear doesn't have any expressions. So we can recognize using ear also of any person. Can recognize. That is a established technique. I'm not the first one. Established technique. The ear is also unique for each one. So we collected data for ear also. So these are the images of newborn ear. Newborn ear images. But fingerprints you can't get. Fingerprints. All are screen. Cannot get fingerprints. Funny. Takes time. So these are the. Okay, the occlusion is also blood images. Apart from that, we saw that this may be also unique. So we collected the data of head print also. So we collected as much as data that we could get. So that when we are taking effort, so why not collect all the things? Whether it can be of any use or not, but it was not that much use. And apart from that, we collected some soft parametric data, like weight and other things. Height, weight. The accuracy of our model. So as you can see here, the same question that I asked you. Who is better? Machine. Yeah. After machine, then the machine doctor. See, mother is very good at recognizing her child. Very good. But not all the child. Doctor is better than mother for recognizing general. वहां का होता है ना, टीचर वो अपने बेटे को एक बार हो गया तो फिर वो कहीं पे भी रहेगा बच्चा, वो किसी भी तरीके से वो पहचान देंगे, कहीं पे भी रहेगा बच्चा उसका. That is what it is. So mother is very good at recognizing her child. Doctors is better than mother. Okay. So these are some of the old techniques. This is what we did this one from Shikha ne kiya tha, this one long time right. It's the work of Shikha. What I'm presenting here, this is the work of my research scholars. So this is the accuracy that for papers you can go to my site and can get all the papers are here. So this is the accuracy that we got. So that time we use some fusion techniques and other things. And for ear, then we combine this face and ear both. These two tasks is what we had. It was related to look-alike case. Now another task that I'm going to explain about the work which I have done. How much time is left? No.
Sir, I mean, that is up to you, but
Okay. I'll go. And another 10 to 15 minutes, I think. Otherwise, I'll invite questions. But this next task is also a very novel task that we did about this medical vision analysis. So we visited this Indian Veterinary Research Institute and we tried to explain that what problems we can work out. So they have all the good setup. They have clinical laboratory for clinics for animals. So what we did, we collected the data of canine dogs, histopathological data. We can whether they have tumor is cancerous or non-cancerous for dogs collected. So they provided the data from their lab and we did the work on that. So just in short, so as I told you this. So later on what we did, we mixed the data along with the human also to enhance our results and see what is the similarity. And we found that the histopathological images of the canine as well as the human being are same, almost same. This cancerous and non-cancerous case of human being as well as the dogs are same. So this is the motivation for this task. This is how we collected the data in the laboratory. This is not an open source data. This data has been collected. And you can see the classifications. This different type of carcinomas are there. Solid carcinoma and this all medical terms are there. So our objective was to classify whether it is cancerous or not cancerous. And in cancers also we again try to classify whether this different of cancer. That also we tried. These are some of the models that we used. These are some of the results. I think these models you must be aware of. These are Talmud models. Only thing is that in order to bring the novelty, you have to do some techniques so that accuracy can be increased or complexity can be reduced. So this is the generally what we do such. So this was the problem that we addressed during this research. So published many papers. This is one of the what you call purpose. You can go to the slide, please search my papers on my website and the Guru Scholar also. Get it. Work on turn on this. So you can see this all proof is there. Let us work this. Now I think next work I'll say is related to some bioinformatics, that is the textual data. See, in computer science 7, once we know about this deep learning, machine learning, then any data can come. Whether it's text data, image data, video data, it doesn't make a difference. What I focus on is that problem should be good. Good problem should be there, and then you can apply it. If you know this machine learning and deep learning, then there can be applied. Doesn't make a difference whether it is time series data or any data. So here what we did is peptides. I'll just give you a brief that what was the motivation behind this for your. See, nowadays last of is antibiotics or body is getting resistance to the antibiotics. So what people are saying that peptide is the solution. Peptide you get from this what you call plants and animals. So, I can explain in the best way. Have you seen this what you call animals taking any medicines? Why they don't take? Even if you cut a frog and put it in the water after some time it will heal. What is there? It is because of peptides. So what we have to do, we have to find some peptides that can replace these antibiotics. Because antibiotics has lots of side effects. Now our body is getting resistant to many of the antibiotics that we take. Now we have to go for tests that which antibiotic will suit us. Now the situation has come to that level. So research is going on. So we also did the same work here, and we try to predict the which peptides is better for whether it is antiviral, anti-cancerous, or what do you call antibacterial. So these are the things that we predicted, and then this did only this in silico part, that is compared this simulation. Then it was validated in the lab at IBRI. But we have a good collaboration. So whatever we predicted, that was validated inside the lab, and then in vivo was also done. On in vivo, you go for some animals testing before watching. So it has been done up to this what you call to the mouse. They inject the things after the burns, and so they have successfully tested it. That after burning the mouse, they have applied this peptide-based solutions on the mouse, and they got encouraging results. Now they are planning to file the patents. Since they are the animals, in case of these images, they provided the images and then we did. Now what is happening that we are predicting it. Now they are validating in the lab and testing on the animals. Then finally they file the patents, and then something moves ahead, then it can come from some of medicine otherwise. Research. So this was all about this peptides and this. And the work which we did on peptides, it was at amino cycle base. It had only 20 characters are there. For us in computer science, this formatting is what? Text only. So 20 unique characters are there in case of amino acids. The combination of 20 amino acids, they all what you call peptides are there. So this was the what you call motivation that I told you. I told you this peptide-based antimicrobials is required. Here also we tried many state-of-the-art methods. Because ultimate objective is first our objective is to get good publications. Then we move ahead for some products or something like that. So this is the distribution. And so we go for clinical trials. How we have applied the data sets that we have taken from the open source, and then out of that we identified, collected the data sets, and then tried to predict for different purposes because each has whether it is antiviral, antibacterial, or anti-cancerous. So this set norms for that. If this combination is there, then it is antibacterial. So we have tried to bring out those things. This is how we have done our model here. So these are the publications. For some of the publications related to this work. I think I welcome the questions from your side. Any questions, then should I ask? Yes, we open it. The online we I think no question. Oh, yes, yes.
So for identification of animals, why the retina scan or cannot be?
See, first of see, getting the retina image is not that easy, but now our next plan is that to capture the retina images for the diseases also. So we are doing that part. Because not only we are recognizing, now we are moving ahead for this to identify some of the diseases of the animals. So for that we need those images. So we are going for that. But the capturing is not that easy. We have to have what we call that quality of camera.
It is right for identification.
Pardon?
Identification of that.
For that we are not using this fierce and this is sufficient. So we are not going for identification, but we are going for disease diagnosis. This retina part. That is called fundus images. Fundus images, like for human beings, whether it is a retinopathy, whether it is glaucoma, and other things that we are doing for humans, we are planning for animals also. We are going for disease detection.
For the cattle recognition, sir, you have applied both machine learning and your deep.
Yes, yes.
So in both cases, the data set is same. The size
No, no. Once we get the good data sets, then why we'll go for machine learning? We have sufficient data sets and sufficient computing power. Then why we'll go for machine learning? We'll go for deep learning.
What is the size?
See, the beginning we got 500, which is somehow misguided and some augmentation techniques. We reached to 500. Now we have more than that data. Now we have collaborations and we have got funding also. So now we have increased it because now we have to deliver a product. So we don't have any option. We have to deliver them to the private party also. And this what we have completed to the government. Now we are planning to roll out product. Very soon, I hope 2 or 3 months we are planning to test it in the Goshala of Yogi ji. So next 2 or 3 months. That is in the process. So तब वहाँ demonstrate कर लेगा तो फिर तब मान जाएंगे जो प्लानिंग में है हम लोग के लिए लेकिन 2-3 महीने जो है योगी जी के यहाँ दिखाया जाए हमको
Really brilliant is you did.
I want to ask that whether your app should be used. That you develop a mobile app.
Yeah, it is in testing phase. See, at present, once you roll out your product, once you go for this lab only. So at present, we have to deploy it for field testing. It has not gone to field testing. That is what we are planning. Just 1 or 2 months, we go for field testing. Abhi lab mein it's working fine. Now we have to see what are the challenges that we see when we roll out in the field. That we have to test it.
Okay.
Next 1 or 2 months we are planning.
So is it come to public domain? Like some kind of registration you can do with
Actually,
registration?
these things cannot be in the public. Others is large farmhouses people can use, or government agencies they can think of for that.
Okay.
Yeah, government agencies. So once our things are all right, then we can talk to the government, and then government can fund this project, and then we can think of.
And really brilliant idea.
It may go to for this startup level also. We are planning for the startup also. Let's see what I don't know the future, but we are going ahead with it because we have nothing to lose. Because being a professor, we don't have to lose anything. We can do anything as well. What we want.
If anyone is there to ask any question. Offline or online, this is from online mode.
Yeah.
So anyone who wants to ask question available in online mode can unmute and ask the question. Also, anyone wants to ask any question can type also in the chat box. Okay, so I guess there is no more question. Actually, we have heard a lot about human face recognition. A lot of people have done a lot of work on that. But it is quite interesting to see that Professor S.K. Singh and his team is working on recognition of human, like say, animals, animal being around. So it's quite interesting thing, and I feel that this is a new direction. Maybe people who are like available today, and then they have learned from the techniques that is developed by S.K. Singh, Professor S.K. Singh and his team, can be useful for you as well as you can also take like support or help from him.
Yeah, sure.
He will be available. Thank you very much, sir, for a very enlightening talk. It was really interesting. Even for me also, I knew that the earlobes are also like ear is also different for people, so it's unique. It's a very good input to know. Thank you very much, sir, for all those insights and like quite enlightening talk. Thank you.
Thank you.
Now I would like to request Professor Sanjay Saxena to felicitate sir.